Have you ever wondered how a tiny microcontroller chip can adapt its physical pins to perform such a wide array of tasks, from lighting an LED to receiving complex data? General Purpose Input-Output, or GPIO, pin functionality in embedded systems is primarily determined by a combination of the microcontroller's internal hardware architecture and the software, or firmware, that configures these hardware components. The core mechanism lies within special function registers and multiplexers. Each GPIO pin is connected to an internal multiplexer, which is essentially a digital switch. This multiplexer allows the pin to be routed to different internal peripherals or configured as a simple digital input or output. Software, through specific configuration registers like the Data Direction Register, or DDR, sets whether a pin will operate as an input, receiving data, or an output, sending data. Other registers manage features like internal pull-up or pull-down resistors, setting the default state of an input pin. For developers, understanding this means carefully consulting the microcontroller's datasheet, which details the various modes and alternate functions available for each pin. You then write firmware, typically in C or assembly language, that directly manipulates these configuration registers. Most modern development environments provide high-level library functions that abstract away the direct register access, making it easier to set a pin's mode and state. For example, enabling a pin to act as a serial data line instead of a basic output. The true power of GPIO pins comes from their ability to perform alternate functions through a process called pin multiplexing. Beyond simple input or output, these pins can become dedicated interfaces for communication protocols like UART, SPI, or I2C, or generate pulse width modulation, or PWM, signals for motor control. This flexibility allows a single physical pin to serve multiple purposes, significantly enhancing the microcontroller's versatility and reducing the total number of pins needed for complex designs. Ultimately, the dynamic control over GPIO pin functionality, driven by both the hardware's design and the firmware's instruction, empowers embedded system designers to optimize resource utilization and create highly adaptable, efficient devices. Mastering this concept is fundamental for anyone looking to build robust and responsive microcontroller-based solutions.